All right, guys, let's get started with the question on the screen here. So last week, Wednesday, we had been speaking about analytical geometry, analytical geo, and last week, Monday, we've been talking about Euclidean geo, Euclid geo, right? So now what we're going to do in this particular question over here is we're going to take these two things and we're going to kind of merge them together. Okay, and this is the example we're going to start with today. All right, so I know that they want us to prove that this thing is a parallelogram. Now, does anybody remember any properties of a parallelogram? Okay. That's okay, that's okay, my sweetie, that's okay. We're just recapping in any case. Does anybody remember any properties of a parallelogram? This is the part where you quickly go out of your Zoom on your phone and you go back to your screenshots to have a look at all the properties of a parallelogram to remind me. Excellent, good. We know that opposite angles are equal. What else? Hello, Mamelo. What else do we know other than just opposite angles are equal? What else do we know about a parallelogram, guys? Good. Let's say opposite sides are equal. Opposite sides are equal. Anything else? Good. Opposite sides are parallel. Beautiful, Didi. Nice one. Parallel. Good. Anything else? Think about the diagonals as well. Hello, Isayan. It's so great to have you with us again. Good. The diagonals bisect. Good. So, okay, I think we can stop it there. I think this is enough for us to do what we need to do here. Right. Excellent work, guys. Beautiful. They bisect. So we know that. And we know that this point over here where they bisect, this thing over here needs to give us, it's called something. If anybody knows what that point there that I've just drawn in like dark black, what we would look at that as in analytical geometry, pop that in the chat for me. Let's say Pile, that's it. That's what I was looking for. It's the midpoint. Good. So this should be the midpoint because it should break these two up into equal parts, and it should break these two up into equal parts. So now we're going to try and use analytical geometry to solve this Euclidean geometry problem. Now, I already know that opposite angles being equal isn't going to work because we don't have any angles. Okay, but we can use the fact that the opposite sides need to be equal to prove that it's a parallelogram, or we can prove that the opposite sides are parallel, and we can prove that the diagonals bisect. Now, if I had to use analytical geometry to prove that the opposite sides are equal, what would I do, guys? Who's got an idea for me? How would we prove that the opposite sides are equal? What analytical geometry thing would we use? Hi, Mawande. What analytical, anybody? Not gradient, Mamelo, but we are going to need the gradient for the other one. Good. That's it, Ritsepile, the distance formula. So we can find the distance, right? So we can find the distance of DC and compare it to the distance of AB. And if those two are equal, and then we also need to look at the distance of AD and the distance of BC. And if those two are equal, that will then prove that this is indeed a parallelogram. Now, if we had to prove that the opposite sides are parallel, what would we use? Mamelo, this is the part where you say the other thing that you said. What did you say before? Yes, that's it. Amy, you stole Mamelo's answer. I saw you. That was Mamelo's answer. Mamelo was saying the gradient. Good. We can use the gradient here. And we know that for parallel lines, what do we know about the gradients of parallel lines, guys? The gradient of parallel lines need to be what? Hello, Benjamin. What do they need to be? If they're parallel, the gradients must be, that's it. Well done, Amy. That's it, Andre. Good. The gradient of each of them needs to be equal. So this gradient over here needs to be equal to this gradient over there. And the gradient of AB needs to be equal to the gradient of DC. Now, if the diagonals bisect, somebody's already said this, but we've said that if the diagonals bisect, then the midpoint of both of these lines needs to be equal. So the midpoint of AC must be the same midpoint as the midpoint of DB. Okay. Well, Isayan, this is a recap of what we did on Wednesday. Okay, so I'm going to give you guys a few minutes. Okay, I want everybody to pick one of these properties. You can either use the distance formula to prove that opposite sides are equal, because that will prove that it's a parallelogram, or you can use that the opposite sides are parallel by proving that the gradients are equal. That will also prove parallel. Or you can look at the midpoint of the two lines. And if you can show that the midpoint of both those lines are equal, it will also prove that it's a parallelogram. All right, everybody's got 3 minutes. Pick one of those, either number 1, number 2, or number 3. Use one of those properties to prove that this is a parallelogram. Pop your favorite emoji in the chat when you're done. All right. Ramofilo says, good afternoon, ma'am. My screen is black. Teacher Nels, did we help Ramofilo out? Okay, awesome. Thank you. Shoo, Isayan is already done. My word, well done. Okay. All right, if you're already done, give me an emoji and tell me which point did you use. Did you use number 1, number 2, or number 3? One more minute to those of you who have not finished. Lovely, Leah. Love that. Refilwe, I also kind of feel like number 3 would be the easiest. That's probably the one that I would jump to. I would also jump to number 3. Nice one, Takani. All right, time is almost up, guys. Nice one, Offense. All right, guys, that's time. All right, so I'm going to use property number 3 because I feel like diagonals bisecting is the easiest thing, and I can find the midpoint easy enough. Right, so I'm first going to look for the midpoint of AC, and that's going to give me -1 plus 6 over 2. And for my y value, I'm going to get 3 plus 1 over 2, and that will give me negative, I'm lying, not negative, 5 over 2. 5 over 2, and this one would give me just the number 2, right? Because 3 plus 1 is 4, divided by 2 is 2. Now, if I look for the midpoint of BD, I'm going to get 2 plus 3 over 2, and on the other side, I'm going to get 6 plus -2, that's just -2 over 2, and that indeed also gives me 5 over 2, and 2. 6 minus 2 is 4, and divided by 2 is 2. So because both of them have the same midpoint, that tells me that my diagonals bisect. Right. Therefore, I can say A, B, C, D is a parallelogram. All right. Okay. No worries, Mkimoto. I like that one. I like that one. And I knew you'd catch on. You're usually very with it. So I knew Sick, not sick. I knew you were going to stick with us. Cool. So I'm going to do a couple of notes for you guys on functions. Remember, functions are usually functions of graphs. This is what we're looking at. When we talk about functions, we're talking about functions of graphs. And I'm going to do like a bit of a, how do I put it? Like a summary, a very quick summary of everything that you need to know about functions. And then we're going to put that into practice. All right. So in grade 10, or in fact, grade 11, 12, all of them, we only learn of about 4 of these. The first one is the straight line graph. Straight line graph. Then the next one we learn about is the parabola. And then we learn about the hyperbola. And then we learn about the exponential graph. Okay. So I don't really think there's any other graph that we learn about apart from your sine, cos, and tan graph, but we're going to cover those when we do, or we have already covered them when we did the trig section. Okay, so those graphs, the sine, cos, and tan graph, we covered those when we did the trigonometry section. So if you want to go have a look at those, you're more than happy to go have a look at those as well. Okay, they're also on the website. All right, so we know that straight line graphs can usually be written as y is equal to mx plus c. And what do we know the c to be, guys? What do we know that c is? Ah, yes. So what we're going to be talking about right now, Tinswalo, is the mother graphs. Okay. We're going to be looking at the mother graphs of these. C in any of y is equal to mx plus c. What do we know that as, guys? Anybody got any idea? That's it. Oh, you're on fire. That's it. That's it, Nkandla. This is the y-intercept. So the y-intercept is basically where my graph cuts the y-axis, right? And we know that at the y-intercept, x is equal to what? X is equal to 0. That's it. I can even see Teacher Nelly's mouth going 0. I saw that. I saw that. Excellent. Don't give them the answers, Teacher Nelly. Don't give them the answers. All right. And we know that if we ever want to draw a straight line graph, we only need 2 points, right? We just need a y-intercept and an x-intercept. What happens at the x-intercept, guys? What happens at the x-intercept? Who knows? That's it. Retepile and Onako, you guys are on fire today. Good. Y is equal to 0. And when we find these 2 points, we know that the y-intercept lies on the y-axis and the x-intercept lies on the x-axis, right? And when we look for these 2 things, we have actually used something called the dual intercept method to draw our graph, right? Dual intercept method. That's all we need to look for in this case. All right, and that's pretty much what we have to know about a straight line graph. Okay, this is the standard form that they give it to us in. Okay. Oh, yes, sorry, Teacher Nels. Yes, thank you. Thank you for reminding me. Good. And I just pointed at it and I didn't even say anything about it. There it is, M. Okay, good. We know that M is our gradient. Right, when we calculate for the gradient is basically the slope. And M is always equal to, because we'll have 2 points, y2 minus y1 over x2 minus x1. You can find the gradient there. No worries, Kimotoko. It's fine. Remember, it's not even a competition. I just want the answers because it's nice to talk to you guys rather than talk to myself. Oh, no, how you can't be like that. Don't be like that. I have not been practicing my drawing skills. So we'll see how my parabola looks in just a second. Okay, so when it comes to the parabola, we know that the standard form of a parabola graph is y is equal to ax squared plus q. Right. And we know that if our graph faces up like that, smiley face graph, right? Thank you. Oh, CP, love to see it. It's a parabola. Love it. Okay. If my graph is smiley, then that means that A is positive, right? And if my graph is frowny, like that. That means that my A is negative. That's it. Nicely done. Good. Now I have to write parabola because now it's stuck in my head. Parabola. Love to see it. Nice one. Love it. Okay. So now we've got parabola and parabola. We know that if this A over here, this A that we're looking at over here, if it's positive, our graph will face up. If it's negative, our graph will face down. We also know that our graph can also have a y-intercept. Okay, and we know at the y-intercept, x is equal to 0. Right, now the only difference with a parabola is that we do get x-intercepts. X-intercepts more than one, right? And that is where y is equal to 0. But there's a but here, there's a caveat. But if there are no x-intercepts, then that means that my graph is a floater. Okay, it means that my graph is a floater. And what that basically means is if I have my my Cartesian plane like that, if my graph is a floater, it means it sits above the x-axis like that. Okay, do you see how it doesn't cut the x-axis? It doesn't cut the x-axis there. So it does not have any x-intercepts. It will only have a y-intercept. Give me a thumbs up if that makes sense. Excellent, guys. Awesome, awesome, awesome. Okay, so if you get to this, you try to factorize there and you're trying to take out a common factor and it's just not factorizing and you can't get any x-intercepts because y is equal to 0, but there's no answer, that means it's a floater. There are no x-intercepts. Or maybe you just calculated wrong. I don't know. Okay, but that's basically what we get, right? We also know that Q, who remembers what is Q? What does Q stand for? Anybody remember? Anybody? Ooh, not the asymptote. Remember, a parabola doesn't have an asymptote. It has a what? Well, yes, we could call it a y-intercept, but not really. Sometimes it's not that. It's not the midpoint. I'm looking for that certain word. Onako, it has point in it. I'll give you guys a hint. It has the word point in it. Anybody? Good. How high or low the graph is. That's it, Chifaro. Well, you're like, I wasn't here, but you're still giving me the correct answers. Good. It tells us about the y value of the turning point. Good. Y value of TP, the turning point. Right. It is possible that that value would also be the y-intercept. It's very possible. And if it is the y-intercept, that means that our turning point is literally at the point 0, our x value would be 0, and our y value would be whatever q is. Okay, so if our turning point is our y-intercept, then our x value will be 0, and our y value will be q. All right, well done, guys. All right, let's talk about the hyperbola quickly. All right, we know hyperbolas are usually written as y is equal to a over x plus q. Now, we know that parabolas, now I'm saying parabolas, hyperbolas come with what? What do hyperbolas come with that the other, that's it. Excellent. Asymptotes, very nicely done. Good, they come with asymptotes. Good, asymptotes. Now, the x asymptote is where x cannot be equal to what? What can x not be equal to, guys? Oh, I sounded very good. X cannot be equal to 0. Good. And our y value cannot be equal to what? What is our y asymptote over here? Anybody remember? It's not 0. It's not 1. Yes, Bongani. Excellent. That's it. It's Q. Q. Our y-intercept is this Q value over here. Okay. But remember, it's not actually an asymptote. Basically, what it is, it's a vertical shift. Remember, it just moves the asymptote of y up or down. Okay. Yes, technically, it should be y is equal to Q. But because we're not actually writing the formulas for, actually, let me write them. So our two asymptotes, the equations of our two asymptotes is x is equal to 0 and y is equal to Q. So that's where we will find the two asymptotes, right? We know that our x is equal to 0 will lie on our x-axis and our y is equal to Q will lie on our y-axis. All right, so these are the graphs, but these are the things that my graphs cannot be at that point. Okay, so the vertical shift, right? And we also know that if I have A, if A is positive, which two quadrants does A go into, guys? If it's positive. That's it, Mawande. Beautiful. 1 and 3. I was going to expect an and in Afrikaans. I was going to expect an Ian and 3. I'm surprised I'm getting English words today. That's lovely. Good. There we go. Ian and 3. There we go with the Afrikaans. Good. Chifaro's doing the job for you. Excellent. Good. And we know if our A is negative. I do, Didi, I do. Okay, good. And if our A is negative, that's it, Takane, good. Our graph will lie in quadrants 2 and 4. Good stuff. So I'm just going to represent that on a quick graph. Okay, so we're going to do that. We know that this is quadrants 1, 2, 3, and 4. If it is positive, I'm going to make positive purple. We'd have the two graphs here and here. And if it is negative, I will leave negative as blue. Our graphs will be here and here. All right. So that's how we know that we've got a hyperbola, if we've got two graphs that look like that. All right, now the exponential graph normally looks like this. Y is equal to b to the power of x plus q. Sometimes they will add an a over here, and I'm going to add it because it means something when we're actually doing the sum. Now, we know that it's an exponential graph because my x is the exponent. Let me rewrite this properly. A times b to the power of x. My x is the exponent, therefore it's an exponential graph. Who remembers, what does the exponential graph come with? Anybody? That's it. I mean, just... beautifully done. Good. It also comes with asymptotes. Good. But in this case, we're only going to get one asymptote, right? We're going to get an asymptote at y is equal to what? Y is equal to, not the squared. I'll give you a hint. It's exactly the same. It's the same as the one for the hyperbola. Y is equal to what? Same one as the hyperbola? Yes, Mawande. Good. Y should be equal to Q. That's it, Kahelelo. Good. Y is equal to Q. So this thing again, Y is equal to Q. It just means that again, that this is a vertical shift of my graph. Okay. Vertical shift. Now, there are a couple of things that we need to know here, right? We need to know that A cannot, A can equal 1. Okay, so A cannot equal 0. B cannot equal 0. And B cannot equal 1. Okay, These are very important because if A is equal to 0, then A is going to make this whole thing 0. We no longer have a graph. And if B is equal to 0, again, this whole thing will become 0, so we won't have a graph. And also, if B is equal to 1, we're just going to have 1 to the power of 1 and 1 to the power of 4 and 1 to the power of -2. Everything is going to be 1. So B cannot be equal to any of those. It cannot be equal to 0 and it cannot be equal to 1. And A cannot be equal to 0. All right. Now we know, I'm going to need a lot of tiny little graphs for this one because this one is quite important. Okay. I'm going to put another one. And then another one. Yeah. Okay. I think 3 is enough. I think we'll be okay with 3. Yeah. Okay. Cool. Right. So if this A over here, guys, if A is negative, oh, let's start with if A is positive. If A is positive, my graph will go up that way. It will rise in that direction. Okay. If it's positive and not just positive, let me not just say positive. If it's positive and greater than 1, my graph will increase in that direction. Okay. Now, if A is negative, then my graph will be down here. It'll be down here. Right? And if my B, now I'm not going to talk about A anymore, I'm going to talk about B. If B lies in between 0 and 1, if it lies in between 0 and 1, then my graph will look like this. Okay, and that's what will happen to my graph. It will be increasing, it will just be going in the other direction. Okay, all right, give me a thumbs up if everybody's okay with what's happened here. Okay, let's give everybody a chance to take a nice proper screenshot because this stuff is like super, super important. And I need you guys to remember it. Take a nice big fat screenshot of everything. It's very important because we're going to put it into practice in just a bit. I know, Chifaro, sometimes it's like, what, ma'am? Like, do we really in grade 10 know all of this? Yes, your brain is capable of kind of just memorizing and using all of this up. Yes, and Tifaro, it is holiday. It's holiday. So you're not doing any of the other subjects. So there's enough space there for the maths to kind of cook. Yeah, the maths is cooking now because you don't have geography and history. It is not rocket science. It's not. Everything that I've put on the screen, guys, you guys have given me all of this information. Okay, I did not do this by myself. A lot of this you guys have given me. So you guys know, you guys know most of this stuff. On Tangeni, I'm so sorry. Okay, all right. I realize that it is a lot. And Stephen, unfortunately, I'm not going to be able to go back, because this was me talking for 20 whole minutes. So if I have to redo this whole thing, I'm going to lose the rest of my lesson. But I do realize that it's a lot. So I need everybody to take a screenshot because we're going to do a brain break. We're going to be doing a brain break. Yes, that's it, Didi. Tough people will last. All right, let's do a brain break quickly. Are we ready? Are we ready for a brain break, guys? Yay. All right, so we're going to be looking at rebus puzzles, okay, which is like the nicest thing ever. It's like if you ever wanted to go into like graphic design, or you wanted to learn how to do advertising or anything. I have a friend, she's a lecturer at the University of Pretoria, and her entire job is to kind of explain things to people using just words and pictures. And so this is what she kind of gets to do for a living. And this is what what she teaches other university students to do, right? So a rebus puzzle is actually quite nice in that you have to take what's been written on the screen and you have to interpret what they're actually saying, right? So if we look at this over here, this is actually going to give us an idiom, something that we're very used to seeing, idioms, right? Idioms are things like, I've bitten off more than I can chew. You see, Lesego's already ruined this one. Thanks, Lesego's got the answer, right? So in this one over here, I have two closes, so I can say too close, and I have for comforts. So I can say too close for comfort. So this idiom actually says too close for comfort. Okay, too close for comfort. So we are taking, I'm sorry, yeah. See, it's almost like maths, but maths translated into words. Give me a thumbs up if this kind of rebus puzzle makes sense. You guys need to interpret the ones that I'm going to show you next. Okay. Oh, Chifaro, I'm glad. Guys, we've had so much work to do. Now that it's holiday, guys, we're not for time. We can do brain breaks. Okay, awesome. All right, here's your next challenge. I'm going to start you guys off easy. Okay. Leah, really? Okay. This one is easy. Here's an easy one. Who can figure this one out? Yeah, this one is like, Onako got it in like a second. This one is quite easy. Teacher Nels, do you see it?
I do. 1 in a million.
It is, it's quite nice. This one is 1 in a million. See that? 1 in a million. Okay, now don't think I'm gonna go easy on you guys. Who said I didn't even touch the keyboard yet? Ask Kisma one day. Okay, here's the next one. This one is difficult. I want to see who's gonna get it. FYI, I also had to Google the answer because it was very difficult. No, that was too easy. Lesego, oh, I love it. Okay, good. So this Tangani is like, what did stand between I? No, it's I understand. So it translates to I understand. Pretty clever, huh? Nice one. Nice one. Princess like, all I got was stand line eye. No, it's not the one. Okay, they get a little better. They do get better. Okay, here's another one. This one is nice and easy. Anybody got this one? Sorry, Mamelo. Mamelo's like, I'd rather do maths, ma'am. I can't sham. Yeah, Lesego got it. That's it. Yes, absolutely. Chitara, yes, that's the whole point of a brain break. Good. No, Sipe, you don't have to go to Google. But Lesego figured it out. If you look at all of these words, this one is just eggs written in a different way. This one is eggs written in a different way. So all of them are eggs, just scrambled. So the answer we're looking for over here is scrambled eggs. I'm sorry. It was like, I'm hungry, Matuk. I know, this one was quite nice. Sorry, I didn't mean to make you hungry, Kimuturu. Sorry. Okay, let's look at the last two. There's two more. Teacher Nels, do you know what this one is?
Yeah, I do.
Yes. It is. Yay, Teacher Nels got this one. Very nice. I want to know if you guys know this one.
Oh, Michael, is that you?
Well, Nkuri's like, Papa Penny, no, it's not the answer. Well done, Ande. Yes, Ande, that's the correct one. That's the correct one. It's a penny for your thoughts. It's a penny for your comments. Oh, well done, Andy. Nicely done. Did you see that, Teacher Nelly? They're like, Teacher Nelly, you said you're always there to help. Why aren't you helping? Oh, Didi, the word would have to have penny in it in order for it to make sense. Okay. So Papa Penny took me. That's the comment of the day, by the way, guys. Papa Penny's the one.
You guys.
Thank you, guys. You guys are. Okay, one last one. Let's do one last. Okay, this one is easy. This one is quite easy.
Yeah,
this one is quite easy, guys. Very, very nice. Yeah, there we go. Well done, Jonathan.
Well done, guys.
Very nicely done. Jonathan and Mawanda got that one first. Very nicely done. This one is an easy one. I did say yes, Mawanda. I saw you. Good. This one is a bird's eye view. The bird's eye view. Very nicely done. Okay. Isayan's like, "'Twas easy." I know, Jonathan. I know. See, Leah's like, yes, I know, my sweetie. I know. Sometimes it's like some of you guys, like your Twitter fingers, guys. It's okay, Onako. It's okay. It's just a game. Okay.
I also got one. That's okay.
It's okay. Some of these, they were quite, it's not Twitter, guys. In this case, it's just a bird's eye. It's a bird's eye view. All right. Okay, guys. All right, everybody, just let's stretch a little bit. Stretch in and out. Okay. There we go. Birds. Okay, I look like bird's side view.
But it was like, fun. Patamamelo. It was fun though, right?
I know.
It was like a little break from maths.
Yeah, I thought it was like a nice little thing. First bird, the early bird gets the worm. There's no worm. It would make sense if there was a worm. How Chifaro's like, that, ma'am, that wasn't a break. How, guys? I thought it was a break. Okay, fine. Maybe not. Okay. All right, guys. ASCII seeing. Okay. I'll pick a different break next time. All right, let's get back to the maths, guys. Okay, we're going to be practicing a little bit. Okay, so what we're going to be doing, guys, is we're going to be practicing how to get the equation once they've given us a graph. Okay, Mordecai. All right, guys, let's focus. Bring it back. All right, guys. All right, guys. Okay, so we're going to start with this one. It says here, give the general equations. Y is equal to mx plus c, y is equal to ax squared plus q, and y is equal to a over x plus q. All right, so what this tells us is we have got a straight line graph. We've got a parabola. And we've got a hyperbola. And we need to figure out how to put this, the equation of these together, right? So we know that when we're looking for a straight line graph, guys, we need two things. What are the two things that we need? Anybody remember? Oh, it's another graph that I forgot to add in. It's okay, Michael, I forgot to add it in, it's fine. Okay, what are the two things? Ooh, Mawande, it's not going to have a y. It's not going to have a y asymptote. It's not going to have an asymptote. Good, Onako. One of them is the y-intercept, right? Good, Mamelo. That's the other one. The other one is the gradient. Okay, the gradient. All right. So in this case, Ratepile, the y-intercept and the x-intercept won't work because both the y-intercept and the x-intercept are in the same place. Okay, that's why they've given us another point. Okay, so by the way, what is my y-intercept? We can just read it off the graph. What would my y-intercept be? I know that my x-intercept or my x value would be 0. Have a look on the graph, guys. It's not going to be -6. Where does my graph cross the y-axis? Yes, Bongani, good, that's it. It's at 0. My graph crosses the x-axis at 0. So my y-intercept, my c is going to be 0. So at the moment, I've got y is equal to mx plus 0, which is the same as nothing, really. I don't even have to add the mx plus 0 part. Okay. All right. Now we have to find the gradient, right? So in order to find the gradient, we need 2 points. And we've got 1 point over here. I'm going to name this x1 and y1. What is my other point? Where's my other point? Michael's already kind of given it to us over here. He says that the origin. Good, it's the origin. So that would be 0 and 0. Hi, Nkechi. Right. So we'll have 0 and 0. So I want you guys to find the gradient for me. Remember, the gradient is y2 minus y1 over x2 minus x1. And remember, you can't decide you want to write the x values on the top and y values at the bottom. No, no. Y values go on the top, x values go on the bottom. All right, give me an answer, guys. M is equal to something. That's it, Isabel. Well done. Amazing stuff. Awesome, awesome, awesome. That is 100% the answer I was looking for. So I'm going to get 0 minus -6 will give us +6 over 0 minus -2 would give us +2. 6 divided by 2, m is equal to 3. Good. So my equation of the straight line would be y is equal to 3x. I don't need to add the +0 because if I add 0 to anything, it won't change the value. So this is y is equal to 3x. Okay, that is the answer we were looking for. Very well done, guys. Hi, Kiara. So nice to see you. Feel like you've been quiet the entire time unless you joined us a little late. All right, guys, let's have a look at the next one over here. All right, let's have a look at the next one. We have a parabola. And what kind of parabola do we have? Do we have a smiley face or a frowny face? Good, we have a frown face or a sad face. Good, so yeah. Good, it's a sad face. So we know that our A is going to be negative. Our A will be negative. Good, right, our A is negative. And they've also given us the turning point. Do we see the turning point? What is the turning point, guys? What is it? Remember, our turning point would be which value? Which value tells us goes where our turning point is? Which value is our turning point? Yes, Leah, beautiful. The Y value or the Q. Good. The Q is our Y value. So our Y value over here or the Q here will be 3. So now I've got y is equal to ax squared plus 3. How are we going to find A, guys? How do we find A? What would we do? I'm going to write it down here. So I'm going to continue down here. Y is equal to ax squared plus 3. What would we do? Now, remember, everything that they give you on the graph, guys, is very important. It's important information. So they've given us the turning point. We've used the turning point. What else have we not used? What else have we not used? Good, Ande. Sure, Ande, you're on fire today. Well done, good. We're going to substitute, but which point are we substituting, guys? Which point are we substituting? No, it's not going to be the 0,3, princess. The 0,3 is going to give us issues. Good. Yes, that's it, Nkechi. We're going to substitute this value. Now, remember, guys, the x, this one, the first one is the x value, and the second one is the y value. So what we're going to do is we're going to go over here, and we're going to replace y with 1, and we're going to replace x with 1. Right, so my sum will end up looking like this. It will go 1 is equal to a times 1 squared plus 3. Are we then able to solve for a? Can we solve for a, guys? Can I give you 1 minute to solve for a for me? Okay. Anybody have an answer for a for me? Oh, it's not going to be 4. Oh, Nako, be very careful. What happens to 3 when it goes over to the other side? Not 2, guys. Not 2. Remember, a needs to be negative. Yes, Isayan, that's it. Beautifully done. If I take 3 over to the other side of the equal sign, it becomes minus, guys. So I'm going to get 1 minus 3 is equal to a. Therefore, a would be equal to 1 minus 3, which is negative 2. And we've just spoken, guys. We've just had a whole conversation about how our a value must be negative because our graph is frowning. So if you end up with a is equal to 3, you've done something wrong. Or a is equal to 2, then you've done something wrong. Our answer must come out as negative. Okay, so the equation of this graph would be y is equal to negative 2x squared plus 3. This is the answer we're looking for. Okay. All right. Okay. Ah, love to see it. Ooh, teacher knows. Screenshot, Isayan. That is a testament to your hard work. Okay, has nothing to do with what's happening here because you keep coming and you keep on putting in the hard work. Okay. I didn't forget it. But very well done to Isayan. Now I'm segueing. Therefore, I put it in there, just don't say it. Okay, now let's look at this last one very quickly because we're going to run out of time. All right, so we know this is a hyperbola, and we know a hyperbola is y is equal to a over x plus q, right? And we've been given a point over here, right? Now, our two graphs are in which 2 quadrants? Which 2 quadrants is our graph in? Give me the 2 quadrants, guys. Good, 2 and 4. That's it, Kimutluku. So what does that mean about A? What do we know about A then? A needs to be good, Takane, beautifully done. Good, A needs to be negative. Oh my goodness, hi, Palisa. Sure, Palisa, please don't tell me you just got here because that would be very awkward. Good, A needs to be negative, right? And we know that at X, we have an asymptote of 0. There, X is equal to 0. What is my Y asymptote here, guys? Have a look at my graph. What would my Y asymptote be? Good. Q would be what? Q is equal to what, Kahalelo? If we look at the graph, what would our Q be equal to? Good, that's it. It's going to be equal to 0, guys. And the way we can see that is because the graph is approaching the x-axis. That means that my Q value is going to be, that's my Y asymptote over there. So my Q value is going to be equal to 0. Q will equal 0. Okay, so now I've got Y is equal to A over X plus 0. I'm not going to put the plus 0 there because anything plus 0 is just the same. Princess says, ma'am, what if you said minus 1? Then you'd be lying, Princess, because my graph does cut at minus 1. And the whole idea of an asymptote is that it's not allowed to cut at minus 1. Remember, it can't be minus 1 because at minus 1, the graph cuts there. Okay, the graph cuts at minus 1. So you can't say minus 1. Do you see why? Good. I'm glad, Anotida. It's perfect. Let's make the mistakes here, not while we're writing tests. Okay. All right. Last thing that we need to do now, guys, is what other piece of information have they given us? Have a look, because now we have to solve for A, guys. We have to solve for A. What other information have they given us here? Sure, Ntangeni, A is not going to be positive. So we need to, they have not given us an x-intercept. Have a look, guys. That's it, Kimototlo. Good. They've given us these coordinates. And we know that these two coordinates, this is the x value and this is the y value. So we're going to go back into here and we're going to substitute x and y in. We know that our y value will be -1. So I'm going to continue down again. Okay, so I'm going to get -1 is equal to a over 3. And the way I'm going to get that 3 out of the denominator is to cross multiply. So I'm going to cross multiply this that way. Therefore, my a is equal to -3. All right. So I can then say, my graph then says, oh, sorry, therefore a is equal to -3. So I can then say the equation of my graph is y is equal to -3 over x. Okay. Very nicely done, guys.